All right, today we're going to go over the Module 8 test review. Number 1, which function represents exponential decay? All right, so we remember that exponential decay looks like this. Oop, that's growth. To the t. Okay, so this is how our exponential decay means. It means that r, or our b, our base, our common ratio is going to be in between 0 and 1. So we're looking for our b with a number in between 0 and 1, or our r also in between 0 and 1. So let's look at 1. So this one has 1.86. This is growth. This is not an exponential because there is no power to the x. So this is actually neither. Same goes for C. And then D, if we notice, 0.99 is in between 0 and 1. So our answer is D. 2. Complete the given sentence to classify the function below as representing growth or decay. F of x equals 100, 1 plus 0.5 to the x power. The function can be classified as representing blank. So let's start with the first blank. It says exponential growth or decay. Well, remember decay is if our rate or our common ratio is between 0 and 1. If it is growth, it is greater than 1. So let's look at, in this case, we have 1 plus, so I already know automatically it has to be growth because 1 plus anything is going to be obviously greater than 1, so that is growth. The reason it's growth is because of the 1 plus 0.5. This 100 represents your y-intercept or your initial value. It doesn't have really much to do with determining growth or decay. Okay, and then finally, is between is greater than 1. This number, our b, is going to be greater than 1. It's going to be 1.5, which is greater than 1. 3 says a state's annual revenue of 5 cities in T years after the year 2020 are given as functions. Which of these functions, R of T, may be used to model the cities that show a growth by a constant % rate each year? So like 2 that apply. So first hint, we know that we are selecting 2. Next thing we need to remember is we are looking at growth. Now again, growth means our B has to be greater than 1. Okay, so let's look at A. Well, again, 1 plus anything has to be bigger than 1, so we know A is the answer. This has a 9 over 5 to the negative t. Well, I know negative, we remember our laws of exponents. Negative turns something into the inverse, so this is not going to be it. C, if we look at our B in this case, B is less than 1 but greater than 0. So it is also not an option because this is going to be decay. D, again, 1 plus 0.99, that is going to work. And again, this is less than 1, so it is decay. Number 4. Look at the graph of the exponential function below. Which of these represents the function in the graph? Okay, so let's start by rewriting our formula so we can figure out what goes where. So we know A is our y-intercept. Let's start with our y-intercept. Our y-intercept in this case is where my graph touches the y-line. My graph touches at negative 2. So my A should be negative 2. So I can already eliminate A, and I can eliminate C. So now I'm looking for my common ratio. We can find our common ratio by taking 2 points, and remember we travel left to right. So my first point can be this 0, negative 2, and my very next point is 1, negative 6. And I want to know, how did I get from 2 to negative 6? Well, we can do y2 minus over y1, which is negative 6 divided by negative 2, which is 3. So my common ratio should be 3. That makes it D. Number 5. What is the equation of an exponential function corresponding to the following table? So let's start with, I already can identify my y-intercept. Because when x is 0, I know this is going to be my y-intercept. So my problem should start with a of 1 over 3. The only ones, well, we can eliminate A and we can eliminate D. So now I need to figure out, and this is A. Now we need to figure out how did they go from 1 to 3, from 3 to 9? Well, I know they did times 3, because if I go the opposite way, I know 3 divided by 1 is 3. I know 9 divided by 3 is 3, so my common ratio is 3. The only one with the common ratio of 3 is B. All right, for the next one, it says John borrowed $600 as a paid down loan. If John does not pay the money back, the amount he owes will go up as shown in the following table. Which equation can John use to find the amount he will owe if he waits M months to pay back his loan? Okay, well, we know that over time, the amount that he owes is increasing. So I know this is going to be growth. So the first thing I can eliminate is D because that is decay. All right, now the next thing I want to find is the common ratio. I want to figure out what my B is. So I can always do y2 divided by y1. y2 divided by y1. So I'm going to do 752.64 divided by 672, which is going to give us 1.12. So this is going to be our common ratio. So let's see if based on this we can figure out our answer. Well, 1 plus 0.88 gives us a common ratio of 1.88, so that's not going to work. This is going to give us a common ratio of 212 and 112. So now be careful because even though it says 212, I'm looking for 112. So my answer is going to be A. Now let's say I wanted to find my initial value. I could also find A. I could plug in, I'm missing A, but I already know a point. I can use 672, so I'm going to put 672 for Y. I know my common ratio is 1.12, and I know my X is 1. And that could also get me 672. 1.12 to the first power is 1.12a divided by 1.12, and that's going to give me A equals 600, which is also my initial value. All right, number 7 says, which of these represents the graph of f of x equals -4 times 2 to the x power? All right, so let's start labeling. We know this is our y-intercept. So let's start by finding y-intercept of -4. So A, possible answer. B has a y-intercept of +4, so we can already eliminate. C has a y-intercept of -4, and D also has a y-intercept of +4, so that's not going to work. So now let's look at our common ratio. Our common ratio is 2. Now, we could do a little table. And we already know our first value is 0, -4, because that's our y-intercept. So let's try if we plug in 1. Well, 2 to the first power is 2 times -8, or times -4 is -8. So my next point should be 1, -8. 1, -8. Okay, this one matches. We already said B wasn't an answer. 1, -8. This point does not match on my graph. So I know my answer is A. Okay, which of the following features best represents y equals 1 over 3 times 4 to the x power? So y-intercept is 1 over 3. Now that should be somewhere between 0 and 1. Well, they both have a y-intercept of about 1 over 3. So my important part here is going to be my common ratio. Now, in this case, I don't have any very next point, so it's a little bit hard to tell what's next. But I do know that 4 is greater than 1. That means this has to be growth. So if I put my little person on the mountain, he should be going up the mountain. In this case, he is. If I put him on graph B, he's going down the mountain. So I know my answer has to be A. Now, I could also plug in to see if the pattern's going to be right and make my own graph. but we'll keep going for now. Okay, so C says the y-intercept is 0, 4. Well, we know that's our common ratio. 4 is our common ratio, so C is not going to work. D says the y-intercept is 0, 1 over 3. Well, that's true. E says as x increases, the value of the function increases. Well, I know this is my correct function. So as these numbers get bigger, it does look like my tail is going up. So E will also be an answer. Now let's look at F. As x increases, the value of the function decreases. Well, we said as this goes up, as x is increased, my function does not go down. So that's not going to be it. The domain and range are both all real numbers. Well, I know my domain is going to be all real numbers because both my arrows go on forever. But this graph has an asymptote of 0. That means this graph will never cross the 0 threshold. So it does not have a range of all real numbers. H, the domain is all real numbers, but the range is greater than 0. Yeah, my asymptote is 0, so that means every y value has to be greater than 0. So H will be an answer. Okay, number 9. Graph of a certain exponential function y equals m1 plus n to the x power has these characteristics. It has no y-intercept or x-intercept. It has a positive y-intercept, and the graph is increasing. So let's start with it has no x-intercept. Well, that means it's never going to touch either x line. We can't really tell that from the numbers here. So let's try a positive y-intercept. I know my y-intercept is my m. So we need to make sure that number is positive. Well, anything with a negative m can be eliminated. So that takes out C and D. Positive 3, positive 3. My graph is also increasing. That means my graph has to be a growth. So B has to be greater than 1. Okay. Now remember, B is the entire 1 plus. So let's try plugging in A. So if 1 minus 1/2 is a half, that means my B would be in between 1 and 0. But if I plug in a positive half, 1 plus a half, I get 1 1/2, which is greater than 1, meaning my answer is B. In 2010, Carlos purchased a car whose value, y, after x years is given by y equals 52,651 times 0.45 to the x power. What is the correct interpretation of 0.45 in this equation? Okay, so this is our common ratio. Before it was this, it looked something like this. We had a rate. So we had a rate here that led us to, when added or subtracted, became 0.45. Well, the first thing I know is this is in between 0 and 1. So this was a decay. So that means this had to have been a negative. Now, if I want to figure out the rate, I'm going to do 1 minus 0.45. And that's going to get me 0.55. That means my rate was 0.55. So I'm looking at what does the rate initially mean and how does it lead to the 0.45? Well, if I know it was a decay, I know the car's value didn't increase, so I can eliminate anything with an increase in it. So I know that my car decreased in value. Now, first option says it decreased by a 45%. And although we did multiply by 45, the rate was actually 55%. So my answer should be D. Number 6. You deposited $6,200 in a 3-year CD account that pays 4% interest compounded semi-annually. What is the ending balance? All right, so we can use our compound interest. A equals P1 plus R over N times T. So let's start with our principal. Our principal was 6,200. 1 plus, always part of the problem. Our rate was 4%. Well, 4% as a decimal is 0.04. Now, it was compounded semi-annually. I know that happens twice a year. So I'm going to divide that by the n, number of times it's compounded, and I'm going to plug in 2 for the number of times it's compounded times our time. This is a 3-year CD, so I put the 3. Now you plug the whole thing into your calculator, and you should get $6,982.21. Make sure to round if need be. 5 or more, make it so. 4 or less, let it rest. In this case, there was a 2 at the end, so we did not need to round. And finally, your friend Jenna deposits $3,500 into a 1-year CD, a type of savings account at an interest rate of 4.86% compounded quarterly. Your friend Casey deposits the same amount of money into a savings account, earning simple interest at the same rate of 4.6. At the end of 1 year, they compare the amounts of money in their accounts. What is the difference between the balances in Jenna and Casey's account? So Jenna compounded her money quarterly, and it was compounded. So that means we're going to be using our compounding formula, which means we start with the 3,500. 1 plus, our rate is 0.86, which as a decimal is 0.0486. So we can put that on top. Now it was compounded quarterly, which means that's going to happen 4 times in a year. So we can divide that by 4. And it's going to be over the course of 1 year. All right, once you plug this into your calculator, and make sure you plug it in exactly as you see it. You could also do the division part first, the fraction, and then plug it in, but it might be easier if you just plug in the whole thing. Once you plug in the whole thing, we get 3,673.23. Remember, if you need to round, round. In this case, we had to round. All right, and next it says Casey deposited the same amount, so we still have our 3,500, but hers was based on simple interest. So our simple interest formula is our P1 plus RT. It is not compounded, so there is no exponent. So we're just going to plug it in. Principal was the same, 3,500. 1 plus, our rate in this case is the same, 0.0486 times our time, which was just 1 year. And again, you plug that into your calculator just as you see it, and we get 3,670.10. And now it wants to know the difference between the two. Well, I'm just going to subtract these two. Once I subtract, I get $3.13. And that is our Module 8 test review.